Welcome to my channel. In this video, we'll be covering a tree data structure. Okay, so I'll be implementing a tree, a simple tree using C program. Before that, let's see how the tree looks like. Okay, so then you'll have some idea about the tree data structure so that I can navigate you for the implementation. So you know how the tree data structure will look like. We'll have always a root, and each root they'll be having at least one child. Okay, so I can just have at least one child and at most two child. Okay, so it can have the maximum of two child and minimum of one child. So when you have a tree structure like this, then I can say it is a binary tree. Okay, so now what we have to do is we have to implement a tree like this. Okay, and I need to store the value over here. So this is my root and this is my left child and this is my right child. Okay, so this is my case. Okay, in this case what I'm going to do, I'm going to create a tree like this. So where I'll be having a root and I'll be having a left child and the right child. Okay, now let's start with implementing a program, a C program. Okay, so how to create or implement a simple tree. Okay, starting, we'll be going to the online compiler and we'll start with implementing by using a linked list. We'll start a implementation of tree using a linked list. So starting, what we have to do, we have to just include all header files. So I'm going to use an mlog clog. In that case, I'll be using a library called stdlib.h. So this is where I can use a dynamic memory allocation. Okay, later on I have to define my structure, okay, of the node, what I'm going to create it. So for that, to define the structure of a node, because what I'm going to do is I'm going to create a node in which I'll be having a three members, okay, like this. So in the middle we'll be loading a data. Okay, here I'll be loading the address of the left child and this is my address of the right child. So this will be my structure of a node. This will be my structure of a node. So where my structure of node will be, okay, in between, okay, I'll be storing the data, whatever I'm going to load here. And this is my address. Okay, whatever I'm loading this left child, okay, the address of this will be loaded here and the address of this will be loaded here. Okay, that is what we are going to create the structure of the node. I'll just create B tree node. Okay, so this is my name of the structure. And here we already discussed, we have three members. So where I'll be having a data and I'll be having a node pointer which represents, okay, which represents the address of the left tree. Okay, okay, and then next is of storing the right child. Okay, so I'll be creating that also for right. So now what we did, we just defined the structure. Okay, my structure is like this. I need a data. Okay, so int data represents this particular member, this one. Okay, and this is the address of storing the left child. So this one, actually we are going to have the address of the left child. This is a pointer and this is the other pointer to store the address of the right child. This is my structure of a node. Okay, so later on I'll be creating, okay, I'll be creating what, I'm going to create a structure variable, so where which I'll be creating a node actually. So I'll be having this bt node here. Okay, and I'll be defining a method to create a node. Now this is to define the structure of the node and now I'm going to create a what, a node, new node. Okay, so here I'll be creating create node method. Okay, or else I can just give create, no, anything, create bt node. I'll just create like that. Create a bt node, so which takes up the value to be inserted into the data. Okay, and to define this method, what I have to do is, first thing is like I am going to create a new node. Okay, so new node is, I can just have new node. You know how to create a new node, right? We use mlock of size of bt node. Okay, because this whatever you have here, it is a structure, right? So this is a structure pointer, so no need to mention structure again, you have no need to mention that. Okay, if you're giving bt node, it is nothing but it is indirectly meaning the structure of the node. Okay, next I'm going to insert. Okay, I'm going to what, I'm going to insert the left child and the right child. So here again we'll be having a node like this. So this also, this is nothing but your right subtree and this is nothing but your left subtree. So like that. Okay. So again, if you have this one more child here and one more child here, and this is my value of this. Okay, same here. Again, we'll be having a left child and right child. So this is exactly like this. So now I have created 20 here, right? Again, this can be have a left and right. Again, this can be have left and right. The same structure I have drawn by using a linker list. Okay, so now I have created a new node. So now what I'm going to do is I'm going to have if condition here. If my new node is not equal to null, because starting when I have this thing is created, it is assigned to null in main function. Okay, if this is not equal to null, what I'm going to do is I am going to insert my left and right. Okay, so new node. So here I have given left, right. So same thing you can give here, left equal to null. I am just assigning now new node of left and right. New node right is equal to null. That's it. Okay. And what I am going to do is next I have created new node left, I have created new node right, but I forgot about data. I have to include that also. New node data equal to, so I have given as value here, either you can give value or you can just give bt value, anything. Okay, okay, you can just give bt value. I'm going to assign this, okay, to the data. Okay, I'm going to give the value to the data now. So three things for a node, I have to have three members, all three members have been initialized for the new node. Okay, this is what happening now. So this particular method creates a new node and it just allocate the left to null and right to null. Okay, this is not pointing to anywhere now, it is just initialized with a new node is created. When this method is called, a new node is created like this, a new node is created. So with what, with three members. Okay, so which means that this left is null, left is null and the right is given to the bt value. So where I'll just load that value here, value, and this is also null. Okay, this right is also null. So it is not, nowhere is pointing it, it is nowhere is linked with. Okay, it is a single node we have. Okay, so now this is created like that. After that what we have to go give, actually, as this is a bt, okay, the return type is the structure, we have to return this structure. So what we'll do, we'll just return the new node. Okay, that's it. So this method normally creates a new node and just assign the three members, the left, right and the data. That's it. Okay, the method for the creation of node is created. Okay, next thing is like what we are going to do is we are going to have the main function. So in the main function what I am going to do is I simply call and create a new node. Okay, so here I'll just give bt node, I just have like new one equal to create node of, because this create node of it's take up what, one value. Okay, so I need to pass one integer value, I'll just pass it as 10. Okay, so same thing you can copy, copy and paste it. So this is for creating second node, so I'll just give as 2 and I'll change the value as 20. Okay, and then I'll be creating one more node, so where which I'll be having 3 here, this third node, and this is 30, the value is 30. Okay, and I'll be having one more node, 4 and 5, I'll just have it as 5 nodes. So I'll be having 4 and this is 40. I'll just give the value 40. You can give any values. So again you can just paste it here and give the node number, which is nothing but 5. Again I can change the value to 50. So now I have created 5 nodes, okay, with the same structure. What the structure is? The structure has the value and the left pointer and the right pointer for the childs. Okay, now once your node is created, what I have to do is I have to just tell that which is root and which is a left child and right child. Okay, now so you can see here this particular line creates a node with value 10, and this node creates a value with 20, this node creates a value with 30, like that. So now what I'm going to do is I'm going to manually identify the root and declare the root. I say this new one left equal to new 2, which means that the new one left, this is my new one. Okay, I have been declared as a node with the value 10. Okay, this particular node creates the a node with the structure value is 10. Okay, this is my structure of the new node and the value 10 is loaded here, and I say this new one left, before it was null, I'm telling now I'm going to add the new 2, the address of the new 2. So now this is my new 2. Okay, I'm going to add this to the left child of the root. Okay, I'm just say this is my new 2. So new 2 node will be added as a left child of the new one, and the same way new 3 as the right child of the new one. This is my new 3, and this is will be added to the root of as a right child. Okay, again what I do, I just extend the right subtree. So right subtree is a new 3. So in this I'm going to add the new 4 as the left child of new 3. Okay, what I'm going to do, I'm going to extend this right subtree. So this new 4 will be the left child with a value of 40 is added as the left child of the right child of root. Okay, and the same way I'm just giving new 3 right equal to new 5. I'm just assigning new 5 as the right child of the new 3. Okay, with a value 50. Okay, and now this value of left is null, nowhere it is linked here, and this is left is null, and this is also null, and this is also null. Okay, there is no child for new 4 and new 5. Again this is also null, there is no child for this, and there is no child for new 2, right? Okay, so this is what the structure we are going to create. Okay, this particular method creates a structure of tree like this. Okay, now what is the thing, the new one is the root. Okay, so this is how we have been like completed the main functions. So what we did, we just defined the method for creating a node, and just we used a main function to call the node. And what we did next thing is like we have been just design a tree by declaring it as a root, this is a left child and this is a right child. Now next thing what we have to do, we have to define a method to display or to print a tree. Okay, I'll just say that a method definition here. I'll just say print btree. Okay, and this tree takes up, what it is going to take up, it is going to take up the root, which particular node will be taking up as a root. Okay, I'll just take bt node. Okay, and then I'll just say root. So root is your new one, right? So that will be loaded and that is passed as a parameter. And okay, before that I'll tell you like what I needed. Okay, I'm going to always print as pre-order. Pre-order is nothing but what? Printing the root first and then left subtree and then the right subtree. This is my order I'm going to always follow to print the tree. Okay, so here and that way I have been taken as a root here, and the thing, okay, I'm going to print it now. I'll have it like this way. Okay, this is like what I say, if my root, okay, if my root equal to null, okay, I have to say that there is nothing in the tree, right? I have to print f, it's an empty tree. Okay, if my root is, I don't know how, do not have any children for the root, but still it is a tree, but it is empty tree. Okay, so this is exactly like I have a root. Okay, I do not have any left and any right child, then it is an empty tree. Okay, I just give semicolon, and then what I have to do, else I have to do what, I have to just print the value. Okay, I'll just print off the value here. So value equal to, what I have to print as a pre-order is considered, I have to print the root value. Okay, first thing will be root value. Okay, then what I have to do, then I have to say left. Okay, because I'm going to print the left value. So same thing, can just copy and you can paste it. So what I have to do, I have to print the left. Okay, this cannot be do like this, because it is a left subtree, right? So I have to take up this and I have to call the function as a recursive function. Okay, I can just call this as print b tree of, like this, because this is completely again a node, right? So again I have to call this function to print the complete left. Again we'll be having a root of left subtree, again we'll be having a left of that and right of that. So again it is a tree, is a small tree or subtree. So that is where I call the print btree method for this, to print the left subtree of the root. Okay, starting I have printed root value and now I have printed the left subtree. Again I can just have this, I can just say this is left subtree. Okay, I'll copy this. What I have to do after that, as a pre-order, I have to print the right subtree. Right subtree. Okay, so then I have to change this as right. That's it. Okay, so now I have called everything pre-order as like root is completed, left is completed, and then my right is completed. So here this print tree is completed now. Okay, so after executing, so we got the output. So I had some errors and I just tell you like what are the errors I got, and I have rectified that. So the error is like I've got, so instead of this I didn't use struct here, right? So before you, without using struct, I'm getting errors. So it is completely compiler dependent. So this compiler takes up all the struct in each and everywhere. So here you always like see that your compiler is accepting without struct or with struct, because we already defined the bt node as a structure, but I can use without structure also. But the thing is like the compiler is taking up the keyword each and every time. Okay, so I'll repeat the code now, what I did. So starting I have been defined the structure of the node. So my structure is like I have to have the data and I have to have the pointer for the left child and pointer for the right child. This is my structure of the node. To define that, okay, after that what I did, I have been creating a node by using this method. Okay, so in this case I'm going to create a method in terms of a structure. Okay, this is my a method which comes under the structure of the node, because I'm going to create a node in this structure only, right? So in this case I'm giving structure bt node, and then I create a pointer as a method name called create bt node. Okay, this particular method takes up the value to insert into the as a data. Okay, so this is my data here. Instead I have been, instead of data I have given bt value in a different way. Then we can just initialize the data with this bt value. Okay, in this create node, and what I'm going to do, I'm going to create a new node. The structure or the syntax of creating a new node is structure bt node, and it is a pointer a new node equal to, okay, this mlock returns a void pointer. This void pointer has to convert to the cast typing is nothing but as a structure pointer. So structure bt node star, this is a pointer. Okay, this is my cast type. After this, I am going to give mlock. To use mlock, I have to use a header file stdlib.h. Okay, and this mlock takes up the size of this particular structure. Okay, structure bt node. So this is where you create a new node. This particular syntax, create a new node. This syntax define the structure of the new node. Okay, so next, after creating a new node, I'm just telling that if my new node is not equal to null, okay, then I'm going to do what? I'm going to insert, okay, I'm going to assign my left, right and data, because a new node has three members. So new node left equal to null. So in the starting of the video only I told how the representation has been like drawn up. So new node left equal to null, and then new node right is equal to null, and new node data is equal to this value. Okay, whatever the value of passed in this method, that will be the value assigned to the data. Okay, then this method returns something, right? So it returns the new node because it is going to return the structure of the node. This is my structure node. Okay, so the entire definition creates a new node, that's it. Okay, we have to write this method, we have to write a new node creation syntax, and then we have to assign a new node with a left, right and data. Okay, this is what we define the creation of new node. Next, in the main function, what we did, we just creating a new node now. So I'm just creating a new node like this by calling the method with a value 10. Okay, so in this value, I know I need a new node to be created in that structure by inserting this 10 as the data. Okay, once you call this method, this goes over here, this goes over here. This is nothing but create node of 10. Okay, bt value is 10 now. So the new node data is given as 10, but left and right will be null only. Okay, so each time a new node 1, 2, 3, 4, 5. So 5 nodes is created with the values 10, 20, 30, 40, 50. Once each and every node is created, what I did, I manually declared, okay, new node 1, which is nothing but my root. New 1 left child is new 2. Okay, I'm just going to tell that the left child of new 1 is new 2. Okay, the right child of new 1 is new 3. You can just represent like that, and also have showed that representation how the root, left, right has been like got the places and positions. Okay, so now I have just declared and initialized the new one left and new one right, and new 2 left and new 2 right, and new 3 left and new 4 left, everything. Okay, each and every node, they have three members, left, right and data. Okay, after that I'm just printing the tree. Okay, so always you have to start with root. Okay, here my root was new 1. So here I'm just calling the method called print bt with the root is nothing but new 1. Okay, this is completely printing the b tree structure. After calling this method, it is going to the definition of this method. This is my definition. Okay, what is taking? It is taking the root of the tree. Okay, my root is nothing but in my structure. So structure bt node root. So here, if my root is null, okay, after taking up inside the root, okay, I'm just checking with the root now. If my root is null, I have to print, say that it is an empty tree. There is nothing there in the root. It is empty tree. Okay, next I'm just printing up the value which is inside the root. So always your display or the traversing of the tree will be pre-order. Okay, where we'll be printing the root first, left subtree and the right subtree. So root data will be printed. Next, I'm just going to print the left subtree. If my root left is not equal to null, okay, if it is there, nothing is there now, I'll be printing it is an empty tree, only root value will be printed. If your root left, okay, where which I'm just taking the left subtree, that root, okay, if that root is not equal to null, then I'm going to print the left subtree. Again, what I'm going to do, I'm going to print the root of the left. Okay, so in this case, I'll just print the root left, completely left subtree. Okay, so root data is printed, and then taking up the left subtree, and then the same like you can just print the right subtree. Okay, this is recursively calling the method print b tree of root right. So again it will be taking that as separate subtree, and again we'll be having a root left right like that. Okay, each time you have to check the condition whether your root is equal to null or not. Okay, so here this method they print the values. Okay, all the complete structure of the tree will be printed, and whatever the values inside the tree will be printed here. You can see here value equal to 10, which means this is my new node. Okay, new node 1, which is a root. Okay, root value is 10 because I have inserted a new node value is 10. Okay, 1 is 10, so which means new node 1 is a root, and then starting with the left subtree, this is exactly like, okay, I can just show that. So this is value is 10, so I can just say this root value is 10. Okay, and then this is the left subtree. Again my new 2 will be the left child of this new one. This is my left child, so this is the value is 20. Okay, after that I say here right subtree. Right subtree is nothing but new 3. So new 3 again we have 30 here. Okay, I'll be telling this is a right subtree root. Okay, so this now we have printed root value, left value, right value. Again we'll be taking up the left subtree, which is nothing but your value equal to 40. So which means that here we told that new 4 will be the left of, okay, left of the new 3. Okay, so here this new 4 will be in this, okay, left of a root of right subtree, and then 50 will be the right of right child, 50. Okay, so the structure is now printed and implemented by using SE data structure. Okay, now I hope you people got clear. Okay, you can just note down the program, and if you have any doubt please comment in the sections. Thank you. Happy learning.